Good afternoon, ladies and gentlemen. I'm very pleased to be here and share some of the research I have performed in the Netherlands, Sweden, and also Mexico City. This is my first time in Brazil, and of course on invitation for giving this presentation. But the secret message is to look for as much details as possible for informing the Dutch national football team when we are coming here in 2014 to win the World Cup. So this is my traditional opening slides, traveling around the world. I can't take my real goldfish with me, I always take the pictures. And the pictures, the two bowls, represent a situation that the nature is divided in two bowls, and yours can be sure that one of the two systems will not survive. And that is always a symbol for industrial ecology, that industry working separately from each other could have a good operation and have a better performance in economics, in ecology, in social things. So the central question here is, can industrial ecology, can industry mimic nature and be in one overall system? I'm now living in Sweden. I'm originally from the Netherlands. I moved there 2 years ago, and for your orientation, I have left up Europe, and the red country there, that is Sweden. From this picture, the right one, besides Norway, and somewhere at the north of the south is Linköping. That is how I have learned to pronounce it, but still it will not be okay. When we look to cleaner production, we have gone through the phases of pollution control. That were at a certain moment cleaner production came in. Can we prevent the generation of pollution? Via waste management, when we are covering issues like energy recovery, reuse, reclamation, off-site recycling, to cleaner production with as central elements on-site recycling, source reduction, energy and raw material conservation, resource recovery, as type of shift towards sustainability. And cleaner production was one of the first concepts that had a systems approach, improving efficiency of resource utilization, minimizing creation of waste and pollution, cost reduction and marketing advantage, the so-called win-win approach. And there were also on cleaner production several definitions. The first one was formulated at an expert meeting at UNEP in Paris in 1989. I always have preferred the definition in relation to that cleaner production is an innovation process in which quality, pollution prevention, clean technology and organizational change are tuned to improvement of process, product, service, environmental quality and organizational results. The concept developed further, and from a scientific point of view, you see the institutionalization at a certain moment coming in scientific journals, like the Journal of Cleaner Production, that will have its 20th anniversary next year. You have seen the development of regional, at a world scale, regional cleaner production or roundtables on cleaner production all over the world. And you have also seen that via an initiative from UNEP and UNIDO, a worldwide net of national cleaner production centers have developed. Nowadays there are 49 cleaner production centers in the world. You see the red dots. Nowadays it's called cleaner production and resource efficiency. Nowadays the organization of the cleaner production centers are in 5 regions in the world, and Latin America has been an example of that. That was the first region in the world where the cleaner production centers united in regional meetings as a regional group. But now you have 5 regions with Africa, the Middle East, Asia, and the transition countries in Europe. Some examples that I have got from the Brazilian cleaner production center. The approach we have seen in the introduction of cleaner production all over the world, demonstration product showing a certain situation. In this slide, it's the food sector with the production of bread and confectioning, high consumption and waste of flour in mixing processes, often fueled by petrol, liquid gas, and high energy consumption in freezing chambers. And the gas cylinders are stored somewhere there. After a cleaner production assessment, several issues were reached. Reduction in flour consumption and in flour waste generation in the mixing process by training and adopting best practices. That is on the level of awareness raising, education, etc. Reduction of power consumption through regulation of temperature in chilling chamber. Substitution of metal liquefied gas for electric power in the oven. That are the technical changes. All was resulting in economic savings in the floor cost, about 2,300 reais, and in the energy cost about 6,000, and also results at the environmental field with the reduction in the floor consumption in the mixing, 2,300 kilogram per year, reduction in floor waste generation, and the use of clean energy for oven operation, and reduction in energy consumption. Say the traditional approach in cleaner production demonstration projects. This case study is also illustrative. Before the assessment, the steel sheet cutting with guillotine machines related to the French history. Amount of waste generated, you see the number. And after that, we went to steel sheet cutting with punching machines. And there was an amazing result in cutting the amount of waste with more than half of the waste, and economic benefits. So those approaches have been going on all over the world. The general findings were often the same all over the world. Findings are phrased in the you can't find when you don't know where to look theory. That will say engineers or managers who are reasonable but not intimately familiar with the process may conclude that there are no cleaner production opportunities because we can't see them. Another issue is when an organization doesn't internalize cleaner production, the ability for changing a failure into a cleaner production opportunity can be seen. There was in the Netherlands an illustration of a failure during the yogurt making batch process, that the operator did something wrong and the whole process stopped at that moment. But some hours later we saw that the process of yogurt making was quicker than the original one. So the manager who was knowledgeable about cleaner production immediately showed that what has been done was a failure in the system, but the failure opens the door to a new approach that was even quicker in the production process, and also providing less energy, etc. So, cleaner production and industrial ecology, what that is, I come back in a few slides, are part, in my vision, in a transition process from the current situation going to new routines. Now, we have all learned that that is not a taken for granted change. It takes a lot of time. It takes a lot of processes of awareness raising, information giving, education, demonstration, etc., to come beyond certain points. I have illustrated in this overview as the concepts are being thought, are being brought to society, where major stakeholders are being approached, companies, government, experts, citizens, and trying via those processes of awareness raising, acknowledgement, information, education, demonstration, try to get changes in the system. And when that is happening, you might have an open floor towards sustainable management with the internalization of those concepts. Industrial ecology. It came on the agenda via an article of two American engineers working at General Motors, publishing an article in Scientific American, and we approached industrial ecology as an integrated system in which the consumption of energy and materials is optimized and the effluents of one process serve as the raw material or energy for another process. So very basically, the waste from one company can be a foodstock for another company. Definitions have been evolved. There's also part of a certain development process for a master of industrial ecology in the Netherlands, with participation of three universities. We developed the definition of industrial ecology as the science that studies the metabolism of society, involving the structure and evolution of industrial and consumer activities and their effects on the environment and the ways to steer the metabolism into a sustainable direction. There are close similarities to some other concepts that we know as, for instance, circular economy, that originates from industrial ecology paradigms, building on the notion of loop closing, emphasized in Germany and Swedish environmental policy, and has been pursued by China's environmental policymakers as a potential strategy to solve existing environmental problems. And actually, the circular economy in China has become a strong pillar in the economic development of China. After formally acceptance in 2002, a promotion law was accepted in 2008, and in nowadays 12th five-year action plan, industrial ecology and circular economy are the pillars in the switch from a very, very polluting economy towards a sustainability economy. Another close link is to the cradle-to-cradle concept, not cradle-to-grave, but cradle-to-cradle, that stands for closing loops either at the technosphere, either at the biosphere. So the concept of eco-effectiveness proposes the transformation of products and their associated material flows such that they form a supportive relationship with ecological systems and future economic growth. So the goal is to generate cradle-to-cradle metabolisms that enable materials to maintain their status as resources and accumulate intelligence over time, a type of upcycling. But the basic message is waste is not used anymore as a term. No, waste is a resource. And how can we keep that in the system? What I use as a working definition for working with industrial symbiosis is that it is seen as a process whereby materials, water, energy in the technosphere, and information, organizational and management flows at the institutional level between and among companies are investigated with the objective of developing and improving cooperative links between and among them. So there is the interconnectedness expressed between the physical systems, the technology, the material and energy flows, and the social systems, the institutions, the values, organizations, individuals, the culture, etc. And talking about from that side, we know that human activities are embedded. Yeah? They are shaped by the context in which they occur. A lot of new coalitions don't start at scratch. They are influenced by surroundings or already existing context. Then we face several issues of embeddedness. I put on this file too. The way in which individuals and organizations collect and use information, making sense of information, that can be very different. Using the same information by different people can have different outcomes. So communication and transparency in using information is a very a very strong factor for good approaches. And the rational actor model, that people are rational actors. However, we, individuals, organizations, have limited capacities for information processing and decision making. A simple example of what industrial symbiosis is. This is a simplified illustration of two different companies with input of raw material, fuel, water. The output is, of course, the product, and often the non-waste product is waste or byproduct, water, etc. The same for another company. When they are nearby, you might consider whether you can close some loops between two companies, so you have an organization beyond the two companies and have and can close some loops. and better use waste, raw materials, etc. Then the issue of eco-industrial parks. That has developed as an illustration of industrial symbiosis. And there are several approaches in that. Either it's a planned approach that under the lead of a governmental organization, an industrial organization, or a special raised organization, the construction of byproduct sharing and links of utilities are developed. In Sweden, I met a lot of illustrations of uncovering industrial symbiosis via business links based on industrial symbiosis. Already this type of approaches was developed. And by showing them, by analyzing that, there is a basis for further developments. You also see an anchored tenant approach, that approach among a big organization like a power plant or a beer brewery. Co-siting, I come back to that, and knowing all of that, you can see the synthesis of the different approaches can that lead to other steps. Well, here you see a power plant with a lot of activities around. I'll go through that. But why eco-industrial parks? There are four major issues. Within the park, you can have a higher resource and economic efficiency. Community partnerships leading to better economic development and quality of life. Ecological side, planning and green buildings, and an expanded use of renewable energy. In the community of industrial symbiosis researchers, we often discuss this item. How do you manage, develop eco-industrial parks? With a top-down construction, centralized coordination mechanisms, or bottom-up, decentralized, complex coordination mechanisms. And as a research group, we saw those two different approaches. For instance, in Asia, especially in China, that the top-down approach was the main coordination mechanism, while in Europe and the States, the bottom-up approach was illustrative. Nowadays, this was a discussion some 3 years ago. We decided, well, there are two models of starting, designing, developing eco-industrial parks. Nowadays, those two approaches are coming together, because also in China, I found that, you have to make a certain selection for constructing eco-industrial parks. In the past, the economic growth was so fast that you need no selection, but nowadays there is. The most famous example in the world is Scalenborg, a small industrial estate in the north of Denmark. 25 connections of material and energy flows in 2009 with main actors, a coal-fired power plant, an oil refinery, medical biochemistry industry, a gypsum board manufacturer, a soil cleaning company, and the municipality of Scalenborg. That site developed in a developed in an organic way, step for step for step, was made based on business agreement between two companies, leading to a certain situation of industrial symbiosis. It was remarkable that this industrial estate was an illustration of new approaches during the summit in Rio de Janeiro in 1992. And by that, it received enormous attention for this type of approaches. And the people there, it's a small town of about 30,000 inhabitants, but we were receiving all the big news agencies from all over the world in their in their small town. But it became the illustration for what industrial symbiosis can do, but it became also the basis for planned activities. While the industrial park in Kalundborg had no planned activity on industrial symbiosis. It was based on organic development, managers who know each other in a small community and talked also in other gremia about possible developments. One of the items was utilizing the waste heat of the power station for warming water and having them that distributed in a district heating systems. Here you see the pipe coming from the industrial estate going to the city. We made calculations, rough calculations each year, and this is the savings of 2008. 1.9 million cubic meter of groundwater, 1 million cubic meter surface water, 200,000 ton natural gypsum, 20,000 ton oil equivalents, reduced emissions to air and water, 250,000 ton, and economic savings for more than $50 million. And you must take in mind that it's not a very big industrial park. It has, in an earlier slide, the major bigger companies were mentioned, and as such, it's a small industrial estate. Well, all those concepts, you can see that we have a basis at a certain level of society. I refer to micro, meso, and macro, relating that to micro level as the level of individual firms. That is the level where cleaner production started to be explored and developed. Industrial ecology at the level beyond companies, so in industrial estate, and say sustainability, the concept is coming from a macro level approach. I will not go into all the dissemination issues, but of course we are in strong relation to each other. I start with a research example in the Rotterdam Harbor, an industry area, an area of about 100 square kilometers, where we started with an industrial ecosystem project, acronym INES, in the mid-1990s as a 4-year research program with participation of Erasmus University in Rotterdam and Delft University of Technology. And that project led to 15 industrial ecology projects, and that those 15 projects were further explored in a second program from 1999 till 2002. But in that project, a platform of stakeholders came in, where the 15 projects were discussed and further explored in feasibility studies for realization. And a third program, longer-term program, was the follow-up of that, where a strategic decision-making platform was coming in. And the strategic decision-making platform was a platform with representatives from industry, from government, from universities, from an environmental advocacy organization, from the Port Authority, and that was for the first time a platform where stakeholders could communicate with each other, also in relation to decision-making about certain steps, certain approaches in the industrial area. So this is the overview. And some of the program results, the Delft University and the Rotterdam University had developed joint research teams for developing industrial ecology. Some of the projects are mentioned here, but it was also obvious that the communication about industrial ecology inspired others who saw the information and thought, hey, what is in for our organization, for our business, that several projects and several constructions started besides the planned approach. So the first one, a compressed air supplier, grows from the delivery of 4 companies in 2000 to 70 companies in 2005. That was part of the INES project. But it came out as a new business area for a gas delivery company. Application of low-calories gas in an oil drilling process was also part of that project, and it was very interesting how that went. The oil drilling process was near the Shell refinery plant, and from time to time you saw there flaring. And everyone in the region thought that it was a flaring system of the Shell refinery. Till we defined the project and make clear that it was not the refinery, but the oil drilling company. That most of the time the gas that came up with the oil drilling was put down in the ground again. But from time to time, we had to flare it. And when that was clear, then in 1 week, a business arrangement for utilizing the low-calorie gas was arranged. Another issue, and that was not in the process, but the chairman of the industry association, who was initiating the industrial ecology project, he was, of course, one of the first ones who was informed about results and about the concepts and the project. And he was responsible for designing a new chemical plant, a Lyondell plant, in the area. And he thought, hey, that's a nice approach. And he utilized the concept for designing a new plant on industrial symbiosis principles. Among others, outsourcing all utilities in the new constructed plant. Of course, that was his baby, not from the research team. We saw a heat delivery from a chemical company to a truck cleaning company. I said it's a very big area, so there are many trucks there, and the company to clean the truck is also not just a garage. It's a larger firm, but it was just a matter of making a connection over the street via a pipeline to utilize waste heat to warming up the water for cleaning the trucks. And the final example I use here is the example of the Happy Shrimp Farm. And that was an idea of two young professionals working at the Port Authority of Rotterdam, seeing some reports about the industrial ecology projects, and just discussing with each other, what if we could utilize waste heat, CO2 emissions, etc., to make a new facility. And we came with the idea of breeding king-size shrimps and for selling them fresh to the higher niche in the market. And we're located near a power plant. They called themselves Happy Shrimp Farm. I don't know if the shrimps were happy, but they were delicious. Utilizing the rest heat of the power plant, the waste heat, bringing that in a closed system that way could warm up the water, utilizing the CO2 and the NOx, the sunlight for energy, only emitting oxygen. And the biofuel, of course, it was not so much what was taken back to the power plant. So this idea became embraced in the Rotterdam Harbor and industry area. Why? For the first time you could see something, you could virtualize industrial ecology. Because most of the links, etc., it's just another industrial estate. You can't see it, but this was visible. It was nice, etc. So from the first idea to a first feasibility plan to a first business plan, it took less than 3 years, and from that, private investors came in to realize this Happy Shrimp Farm. Another project was decoupling CO2 from the Shell refinery. You see here the real fence of the Shell refinery, and bring that via pipelines to 1/3 of the Dutch greenhouse organizations. And that's a very big sector in the Netherlands. It's still the second world exporter in the food we produce. So via pipelines system, transformer houses, it is transported to greenhouses at a distance of 80 kilometers. And from that point and the 0 kilometers, several connections have been made. Another approach is co-siting. This was at a former ICI plant, where a decision from the central office in the UK was made that the plant should close down. Of course, a lot of social, economic turmoil at that facility. The director came with an idea, because we had 80% bulk production and 20% very specialized production. He developed a plan, can we keep the 20% specialized production, and try to involve other companies at our industrial site, so we can utilize the existing infrastructure, permits, etc., but then in an industrial ecology system. And of course that took some time, but he realized to develop that idea, and nowadays it's a partial industrial symbiosis system at a site in the Rotterdam area. Another project is utilizing the waste heat of all those refineries. There are 5 refineries from Shell, BP, Exxon, Aramco, Kuwait, utilizing their waste heat for a district heating system. This symbolizes, it's not perfectly seen, but symbolizes a part of the Netherlands, and from where you see Rotterdam to the left, that is an industrial area, and we found out that more than 2,000 megawatt of waste heat was emitted into the air, and some 3,000 megawatt was emitted into the water. So that's enormous figure when you notice that some 15,000 megawatt was the total figure for the electricity use in the Netherlands as total. So it became something also on the political agenda. This could not go on like that. So the idea was to start a district heating system based on waste heat instead of the natural gas system that is the energy system basis in the Netherlands. Well, a long story short, this project was already defined in 1995. There were ups and downs in the calculating of the possibility of the feasibility. There were systems from a pipeline through the whole industrial area, because there were companies who produced heat and there were companies who needed heat. So the connection could be very worthwhile, but economically it was not feasible. Then smaller projects in certain clusters were looked after also. That was not the case. And now still this plan to connect the waste heat emissions to a district heating system in Rotterdam, in Delft, and part of The Hague, it's still there. And since this year, a new company as a joint venture of the municipality of Rotterdam and Aeon energy firm started for a new approach of this development. After several promising developments, even starting making the new infrastructure to stop the project again. Here you see one of the cluster approaches. In this area there are some 20 companies who could, in a mini cluster, go on with this system, with this in development nowadays. Industrial ecology also became the model for a new reclaimed on the sea area for industrial activities. At the left side of this overview with I don't know what type of red colors, that will be the new land, and such projects, of course, in decision making, it takes more than 10 years. During that 10 years, the utilization of industrial ecology as a basic concept for developing a new area was discussed at the Port Authority. Also had its ups and downs. And finally, via a master thesis of a student industrial ecology, the floor was there for the breakthrough to, well, we will develop this area as with an industrial ecology infrastructure. So it was also promoted like that for getting new industry there. This is a picture, an illustration of the situation in Östergötland, a county at south of Stockholm in Sweden, where I'm living now. And this symbolizes, I don't have a pointer, sorry, but symbolize the streams in the energy systems of two cities, were called themselves twin cities, Linköping and Norrköping. But at the left you see the situation in Linköping, and the following deliveries are described. You have in Sweden, you had a choice at a certain moment of the decision for starting a waste to energy system. I will say incinerators of household waste and later non-toxic industrial waste were utilized as systems for making warm water. The infrastructure in the countries was arranged for the warm water delivery to all houses, and in that system electricity was a byproduct. But altogether it reached an efficiency of 90%. So that's enormous. What you also see is the development, or it's in performance nowadays, the links to a biogas plant based on the gas sediments of the wastewater treatment facilities, of old oil from restaurants, from the wastewater from a slaughterhouse. And those who are dealing with cleaner production in a longer time frame knows the problems we always had from a cleaner production concept in a slaughterhouse. It was one of the most difficult organization to tackle in that. But now we are selling the wastewater to the biogas plant. So the biogas plant is fed by some 75% of the slaughterhouse, 1% of the restaurants, 25% of the wastewater treatment facility, and we produce a perfect biogas that is utilized in the public transport system in Linköping, and the same is happening in Norrköping, the other city. So it's a perfect model, and of course also not from one day to another, but realized. But it started with a decision to use incineration in this power circulation process. So nowadays, you even can see that there is a marketing of industrial ecology. We use this approach that environmental problems are turned into business opportunities by applying wide system boundaries, using resources efficiently, and cooperate through resource sharing. That is what the Cleantech Östergötland organization is saying, an organization with membership of both cities, Linköping and Norrköping, and some 100 companies. Now, here are some pictures of that. Well, on biofuels, I don't have to tell you so much here in Brazil. But another idea in the industrial symbiosis program that we are working on now, we have developed and working via products, is again the greenhouse idea. But then in another way, because we have been in contact with a company who is specializing in the concept of urban greenhouses. This is a round model, and within the greenhouse you see a spiral where young plants are starting at the bottom and slowly moving to the top, and then we are ready. And we have also models in a vertical way. You can imagine a building with a column for the elevators. Instead of that is a greenhouse. And well, this model might be a demonstration model in the Linköping area. What you also see is small scale farm biogas digesters in working on a big farm or an association of several small farms, digesting the materials, having energy from that, deliver that to the grid, and the sediments is fertilizer for the land. So you see all type of developments. Now this is development of a Swedish firm that is doing this business in London with getting all the old food or not used food and digesting them towards biodiesel. This is the first biogas train. It's at the track between Linköping and Maastricht, about on the 110 kilometers. It's now some years in operations. We use the old model for that to look if it's feasible. Nowadays there are 3 new trains coming on biofuels. Well, the whole public transport system, I told you. I skipped this. But I'm now involved in a project called Clean Technology and mega cities of more than 10 million people, looking in a system approach that the cities themselves are a source of materials, resources, etc. What's coming in is, among others, in most of the mega cities, gaseous fossil fuels, liquid fossil fuels, water, food, construction materials, diverse materials, often in a linear way going to landfill. But an industrial ecology approach of big cities can mean that you treat the urban environment as an interconnected system, not as isolated subsystems. Linear behaviors are transformed into circular ones, energy and material waste is minimized, links are given special importance, products, materials are converted to another use when their initial use is completed. So, when you can go from linear to circular economy approaches, then you have a lot of material. Well, all over the world, these are the major problems of mega cities: water, food, air, fossil fuel dependency, and the waste management. The waste management issue via landfills was the most acute in Mexico City, we found, because the big landfill there should have been closed 2 years ago. Well, it's still open for another year because not good alternatives are there. The benefits for this way is reduction of independence on fossil fuels and virgin materials. There's a lot of organic waste in cities. You can utilize that. Protection of part of their socio-economic and productive systems from external factors. Increase effectiveness of their planning activities as they would be based to a large extent of their resources. Reduction of the environmental burden. So, for instance, for Mexico City, we found a very, very big example of opportunities for reutilizing all type of resources. For instance, only their central big food market can provide is having 700 tons of organic waste per day, with a potential production of 20 million Newton cubic methane per year. And also the landfill itself, there are so many materials that can be reutilized that there are big potentials in that way. Well, given the time, this is a picture I found some weeks ago about electricity from renewable energy today, and it was very obvious that Latin America was very high, and the other continents, regions in continents, well, we are around 15 to 20%. In that picture, Europe 20%, you must realize that the policy of Sweden, based on earlier decision of being independent from fossil fuels, go to the waste to energy concept, is nowadays already at the level of 55% renewables as basis for electricity. We are far the highest in Europe. But the prediction in this model is that in 2050, the potential is for every region in the world very high in the 90s. But the expectation based on current policies and planned policies is, for instance, that South America is declining as only one. Other areas in the world are increasing to have renewable resources as basis for electricity generation, but still it's far beyond the potential that there is. So that is a real task in the coming decade. Well, cleaner production, industrial ecology. It's often said that you need out-of-the-box thinking. And, well, did you ever see that the energy of system of a camel was extra stimulated by a solar panel on his back? And some time ago, in relation to resources, it was one year ago, in a newsletter of cleaner production in the Middle East, I saw this heading, or Saudi Arabia is running out of sand. What? But what was the case that in the whole area of Saudi Arabia that is all sand, a fraction was from a special quality for being utilized in the construction in industry in countries surrounding. Okay, The future, CO2 and heat. Algae, there are already more than a decade research, discussions, etc. about it. It's still in progress. The question mark is there. I will close with some slides. This was a finding of a panel discussions with Kallenborg veterans that will say that were the plant managers and the representative of the of Kallenborg commune in the 1990s who were at the basis of industrial symbiosis development. And we asked them a question: what were your most triggering experience? And we said, well, we were overwhelmed by worldwide attention from world press, CNN, Time magazine, etc. But our other experience is the social proximity. We knew each other, etc. was a basis for the development. What you need for success, we said, awareness, willingness, and feasibility. And we said our lessons learned is systems make it possible, people make it happen. So, when nature can learn from nature, can't we? One advertisement, I'm organizing the 20th Greening of Industry Network in conference in Linköping next year, so it's in between this biannual, no competition, but I invite you to have a look at the website that will be started in September. So don't miss the point. Nothing is more practical than a good theory. Thank you. Obrigado.